What we are going to start going through is trend lines and scatter plots. They are called trend lines, they are called lines of best fit. We have done these before in other classes. The first thing is kind of just some definitions we're going to go through. So in real world situations, very rarely do things actually follow in a perfectly linear pattern. What does the word linear mean? Line. Nothing really falls in a perfectly straight line. However, we can approximate that with different models. The first model is a scatter plot. A scatter plot is a graph that relates two sets of data by plotting the data as ordered pairs. So a scatter plot is where you have one of those graphs and it's just a whole bunch of dots everywhere. The trend line is then the line that approximates. Approximate, is it going to be perfect? No. The trend line then approximates your scatter plot. The correlation, and this will all make more sense once we start actually looking at them, the correlation just measures how strong it is. So is it a good line? Is it a bad line? Things like that. The correlation coefficient, we'll talk on Tuesday about R. R is a variable. R just tells you, is it a good line? Is it a bad line? It only ranges from -1 to 1. Closer to -1 means it has a negative slope. Or if it's 1, it has a positive slope. So when you look at a line, if the R value is really close to 1, that means that you have all of these dots. And they're pretty gosh darn close to being actually linear. If R is not close to 1, if it's closer to 0, that means that you just have dots all over the place and the line kind of cuts through the middle. When you look at scatter plots, the words strong and weak are used very often. So a strong negative correlation, it's strong because the points are clustered close together. Why would it be considered negative? It's going down. A weak negative correlation, the points generally are still going down, but they're more spread out. No correlation means depending on which way you look at it, you could argue either way. Like if you pick these points, you could say, well, it's positive, but by the same way, if you pick those points, you could say it's negative. So there's no pattern to that. Weak positive, same thing, but now your slope is going up. The way that R plays into it. Now I am making up these R values. When we find R values, we use a computer or a calculator. Like we don't even use the formula. We plug the points in and a program tells us what it is. If I had to guess R values, I would say this R is like -0.9. Because those points, they're pretty close together. I swear the board used to be right here. They're pretty close together, so it's close to 1, negative because it's going down. Since this one is a little bit weaker, negative because it has a negative slope, and I would say like 0.4. Closer to 0 means the lines are more spread out. So when you look at an R value, the closer R is to 1, the better line it is. So the more close the points are. Opposite on this side, this would be positive, this would be negative, or that would be positive as well. So again, R just tells you, is it a good line, is it a bad line? We will use a computer on Tuesday to get our R value, and all it is it tells you, are your points really close together, or are they far apart? When you actually write a trend line, before we go through these steps, look at the last picture I gave you. This is a scatter plot. We have done this before. When you write a trend line, do you want to make it so your line like goes off to the left, to the right, or down the middle? Left, right, or down the middle? Down the middle. You want about the same amount of points above and below. So this is when you guys did this in Algebra 1, where you would sit there and like move your ruler and make sure you have the same amount of points above and below. That's what a trend line is. So when you actually go through and write a trend line, first, plot the data as ordered pairs. once you have your ordered pairs, and in reality, step 1 is going to take the most amount of time because you're going to have to sit there and plot all the points. Sketch your trend line. And when you do that, you want the same amount above as below. And then the whole purpose of you writing a trend line is then you can go there and actually write an equation. So once you have your trend line, you pick 2 points from it and you write the equation in slope-intercept form. So again, when we start doing this on Tuesday, the thing that's going to take the most time is not necessarily writing the actual equation. It's going to be plotting all the points, and then writing the equation will be secondary. I think that's going to be it for today. We'll actually do that on Tuesday.